Hey folks, today we're going to be talking about limiting reactants. So this is the first podcast of this unit. Before we get into limiting reactants, let me talk about chocolate chip cookies, one of my favorite kind of cookies. Frankly, we're going to relate this right to limiting reactants. If you were to go home and you were to try and make chocolate chip cookies, here's the ingredients list over here. Now this ingredients list is straight off of the Toll House cookie box or bag, except for the fact that I tend to use more chocolate chips than it calls for, right? And this one recipe will make 50 cookies, about, more or less. Okay, so let's look at how this actually works. You go home, you're going to make some chocolate chip cookies, and in your kitchen, this is what you have. Right? So what I would like you to do, based on what you have, I'd like you to predict for me how many chocolate chip cookies you can actually make. So pause the video please and see if you can figure out how many chocolate chip cookies you can actually make. Cool. Well, hopefully you did that. Welcome back. And you realize that as you look, for example, at 2 1/4 cups of flour, that since you have 10 cups of flour, you could make somewhere between 4 and 5 batches of cookies. So somewhere between 200 and 250 cookies. And here with 14 sticks of butter, you could make 350 cookies. And here with 6 eggs, you could make 150 cookies. And here with 20 teaspoons of vanilla, you could make maybe 1,000 cookies. That sounds pretty good to me. And here with 30 cups of white sugar, you could make more than 1,500 cookies. And 5 cups of brown sugar, you could make, I don't know, maybe 300 cookies, ballpark. But 4 cups of chocolate chips, you could only make 100 cookies. Because 4 cups will only allow you to make 2 batches, 8 cups will only allow you to make 2 batches of chocolate chip cookies. So you could make 100 chocolate chip cookies, 100 cookies. Now what's your limiting reactant? Well, you had a bunch more flour and butter and eggs than you needed. This is what you ran out of. You ran out of your chocolate chips first. So that's your limiting reactant. So if you think about your kitchen, that's exactly how you figure out a limiting reactant. So what did we do? We looked at all of the products and how many cookies we could make, and then said, oh, well, the one that makes the smallest number of batches, or the smallest cookies, is the chocolate chips. So, you might want to write this down. The limiting reactant, by the way, it's sometimes called the limiting reagent. Don't get freaked out if you see someone say reagent versus reactant. It's essentially the same thing. Right? The limiting reactant is the reactant that limits the amount of product formed in a chemical reaction. Well, that's what we just did when we were making cookies. And isn't making cookies a chemical reaction? It's the one that is completely used up. Now the other reactants, or reactant, you only had one, but the other reactants in our case are in excess, meaning you have more than you needed. And the quantities of products formed, how many cookies we can make, are always determined by the quantity of the limiting reactant. So, since we ran out of chocolate chips, that's what determines how many chocolate chip cookies we can make. Now, there are times when the quantities of the reactants are available in the exact ratio described by the balance equation, which would say to make 100 cookies we would need exactly 4 eggs. We would need exactly 2 teaspoons of vanilla. We would need exactly 1.5 cups of white sugar and 1.5 cups of brown sugar, etc. Right? That's very unusual that we find exactly the right proportions that we want. So usually one reactant or another is used up first. So how do we determine what the limiting reactant is? Well, we have a few steps to take, and I'd like you to write these down. And by the way, I will warn you, we'll be adding steps to this later for other activities. So you're going to write down 1, 2, 3, and 4, but there's like a 5, 6, and a 7 that comes later. Okay. So to determine the limiting reactant, what we do is we write and balance an equation. We choose a product which sometimes is unimportant and sometimes is extremely important, which one you choose. You choose the units of measure that you want to use, because sometimes you could use liters or grams or moles. And then you calculate the amount of one of the products using the masses given. And then finally, number 4, is you determine which reactant produces the smaller amount of product. And that's the one that is limiting, i.e. our chocolate chips. Alright, so let's actually do an example. we have 10 grams of hydrogen gas and 10 grams of oxygen gas, and they react to produce water. How much water is produced? Well, the first thing we have to do, if you go back to your list, is you have to come up with a balanced chemical reaction. So, I'm going to start here, and let's see. All right, I'll start right here on the next page, just because it's a nice clean slate. All right, we have hydrogen, we're adding to it oxygen, and we're producing water. All right, so that's what the equation tells us. But we are smart, and we know that hydrogen is a Brinkelhoff element. It's one of those that's always diatomic when found in nature, as is oxygen. So now when we have H2 plus O2 giving us H2O, we'll notice that there's only one oxygen on the right, but there are two oxygens on the left. So I have to put a 2 coefficient in front of my waters, which means I also need a 2 coefficient in front of my hydrogens. Now I have a balanced chemical reaction. So that's our first step. Now, what I'm going to do, just because I like to do this, is we have 10.0 grams of hydrogen gas, and we have 10.0 grams of oxygen gas. And we don't know how much water we're coming up with. And so we're going to say we have some number of grams of water that we're producing. Now, why are we going to grams of water and not liters of water or moles of water? Well, in our question it says how much water is produced. I'm going to assume that's the mass of water, right? Because moles of water doesn't really tell us a whole lot. We'd rather go to mass of water. All right, so to be able to work through the problem, we need to know a few things. We need to know the molar mass of hydrogen. So I'm going to say the molar mass, and I'm not going to waste your time calculating it here, but for example, the molar mass of H2 is 2.0158 grams. And the molar mass of oxygen is almost 32. It's 31.998 grams. And the molar mass of water, which we'll also use, it uses 18.015 grams. These are all grams per mole because they're the molar mass. Okay, so now what we want to do is we want to go and calculate how much water can be produced based on our grams of hydrogen and oxygen. So let's go ahead and try that. There's H2. And we're starting with 10.0 grams of H2. Now, to be able to get to grams of water, we're going to do a stoichiometry problem. So this is exactly what you guys did in the last unit. So I'll do one of them, and then you can do the next one. Right? 10.0 grams of hydrogens, we have to convert from grams of H2 to moles of H2. But we don't want moles of H2. We want moles of water. We have to go to moles of water. But we really don't want moles of water either. We want grams of water. All right, and then we finally have what our answer is. Now let's see what we have. We have 1 mole, and we know that that's 2.0158 grams. And we look up here at our coefficients, and 2 moles of H2 gives us 2 moles of H2O. And 1 mole of H2O gives us 18.015 grams of H2O. All right. So if I do that math, this tells me that I can produce 89.4 grams of water. I multiply everything on the top, divide by everything on the bottom. You should get 89.4 grams. Right. What about oxygen? Well, oxygen is also starting out with 10.0 grams of O2. All right, your turn. Pause the video. See if you can convert to grams of oxygen, to grams of water. Give it a shot. All right, we are starting with grams of oxygen, so I have to get rid of grams of O2 and go to moles of O2. And I want to go from moles of O2 to moles of water. And then from moles of water, I want to get to grams of water. All right, so let's look at what our conversions are. We have moles of O2, and that is 31.998 grams. and my moles of oxygen are 1 and my moles of water are 2, so that's a 1 to 2 relationship. And every mole of water is 18.015 grams. And when I actually do the math here, that comes out to 11.3 grams of water. So notice that I can only produce 11.3 grams of water. I can't produce 89.4 because I ran out of oxygen too soon. So my limiting reactant is oxygen, so that's limiting. It's what I ran out of first. Right? I have more than enough hydrogen. If I had unlimited oxygen, I could produce 89.4 grams of water. But I don't have unlimited oxygen. So I only had enough oxygen to make 11.3 grams of water. So I have way more hydrogen than I need. Right, so my limiting reactant or my limiting reagent is oxygen. And I can produce a total of 11.3 grams of water. And I think that's what I asked. So, okay? All right, so let's look at our chocolate chip cookie example. It's exactly the same as last time. We can still make 100 cookies. Okay, we can still make 100 cookies because we still have 8 cups of chocolate chips and we use 4 of them per batch. Right? But what's different is, here's my last question. How much flour is left over? How in the world would you calculate how much flour is left over? Right? So give it a moment, think about it, and then tell me what you think. Okay, well, you could do it this way. You could say, I could make 2 batches of chocolate chip cookies, based on this information. And to make 2 batches of chocolate chip cookies, that would take me 4.5 cups of flour. Well, that means I don't use 5.5 cups of flour. And so that's how much I had left over. Right? So that's one way to do it. Another way to do it is say, how many cookies could I have made with my 10 cups of flour? And then say, well, I could subtract that, my 100 cookies from that number, and then that would work backwards into this 4.5 cups, into the 5.5 cups that wasn't used. So there are lots of different ways to do this. So we're just going to pick one, and we're going to pick one based upon the information that we already have, okay? Because we want to do what's easiest for us. Okay, so what we're going to do is go back to our previous slide. Notice that what we calculated was we calculated here how much water we could have produced. Based on our hydrogen, we could have produced 89.4 grams of water, but in reality we only produced 11.3 because we ran out of oxygen. Okay, let's go ahead and use those pieces of information to help figure out what's left over. I warned you there were going to be 2 more steps here, so here's what they are. The first 4 are the same, but what we're going to do is we're going to calculate the amount of product that was not produced. And then from that, we're going to calculate the excess reactant of how much was not used. In other words, we're looking at how much product was not produced, and then we're going to say how much of reactant was not used or consumed. Either way you want to say it, but not used. Interesting work with that pen. Okay, so let's look at what we have, because this is exactly the same problem that we had, right? And you'll notice that we have written here how much we actually got. So if we used our 10 grams of hydrogen, we came up with 89.4 grams of water, and 10 grams of oxygen produced 11.3 grams of water. So what I'm going to do is, this is what was actually produced. So I'm going to say that we have 89.4 grams of water that could have been produced from our hydrogen, but we only produced 11.3 grams of water. That gives us, when we actually do that subtraction, that gives us 78.1, excuse me, 78.1 grams of water. Right? And that's how many grams of water were not produced. In other words, I could have produced them with the hydrogen, okay, but I didn't. All right, so let's actually do the math. This is 78.1 And what is this? This is grams of water. And I'm going to have to do this because I did not do this math correctly. All right, and we're going from grams of water to moles of water. And then we're going from moles of water to moles of, well, what are we trying to figure out? We're trying to figure out how much of the hydrogen we did not use. How much of the hydrogen was in excess? So we want to go back to moles of hydrogen, and then from moles of hydrogen, we want to go to grams of hydrogen. Okay, well, let me stop for just a second. We produced 11.3 grams of water, and the hydrogen could have produced almost 90. So that's a 9-to-1 relationship, about. So we only used a little bit of the hydrogen. So if we started with 10 grams of hydrogen, we probably used between 1 and 2 grams, which means we should have between 8 to 9 grams left over that we didn't use. So that's what this number should come out to be. So let's see if that actually happens. Well, let's see. 1 mole of water weighs 18.015 grams, and our moles of water is 2, and our moles of hydrogen is 2, so we have a 2 and a 2, and our grams of hydrogen are 2.0158 in 1 mole. So I'm going to do the math, and I'm sorry, I'm going to have to do this really quickly. 78.1, so we multiply across the top, and we divide by what's on the bottom, and we get 8.74 grams of hydrogen. So we had 8.74 grams of hydrogen that we did not use. Well, how much did we use? We'll simply subtract that from 10, and that will give us 1.26 grams that we actually did use. So that kind of tells you how we can go and calculate how much material we did not use. Okay, let's go on. Here's another example. Now what I would like you to do as best you can is start this on your own and see how far you get before you need my help. Okay, so pause the video, see how much of this you can do, and then come back. All right, so what we're doing is we are taking copper and we're adding it to a solution of silver nitrate. So we have silver nitrate, and I'm going to go back to that in a minute. Let's just do this. Silver nitrate plus copper should give us, well, this should looks like a single replacement reaction to me. Copper nitrate plus silver. Well, now I pull out my single replacement chart, my activity series. I notice that copper is higher on the activity series than silver, so it will replace the silver. I also notice that copper has a 2+ charge. And nitrate has a 1- charge, so when I cross them, I'm going to have CuNO3, 2. Which, of course, means I need 2 nitrates over here. So I have 2 silver nitrates, but that means I need to have 2 silvers. So I'm now balanced. I have a balanced chemical reaction. That's step number 1. Right, I want to go back and see how much I have. I have 3.50 grams of copper and 6.0 grams. So 3.50 grams and 6.0 grams of the silver nitrate. Right. And the question is, what is the question? What's your limiting reactant? Well, it doesn't tell us whether to use silver or copper nitrate as our target. Does it matter? No, it doesn't. And how much excess reagent is left or reactant is left? Again, it doesn't matter what we go to figure this out. So I'm going to go to silver. And I'm going to go to silver just because it's easier. Now, do I have to go to grams of silver? Well, not really. Because all I care about, because there's nothing in the problem that says how many grams did you come up with, you can go to grams. I'm going to go to moles of silver. I'm going to go to moles just because it's easier and it's one less step, and I'm lazy. Okay, so I don't have to go and figure out how much silver weighs and do all that stuff over here for this side. Okay, don't need to do it. Now, I do need to know how much silver nitrate weighs, and silver nitrate weighs 169.87 grams per mole. And I do need to know how much copper weighs, and that's 63.546 grams per mole. Okay, so let's go and do our stoichiometry problems going up to silver, but stop at moles of silver. Because we can compare moles of silver, that'll tell us which one we ran out of first. Okay, go ahead and see if you can do that. Pause the video, try it on your own. Alright, we're going to do this for silver nitrate, and we're going to do it for copper. We start out with 6.0 grams of silver nitrate. Now we have to get rid of grams of silver nitrate. Now we have to go to moles of silver nitrate. And we want to get rid of moles of silver nitrate. And what do we want to do? Well, we notice that we are trying to get to moles, and we're trying to get to moles of silver. Now we can stop right there because we don't need to go to grams of silver. Okay. Now let's put in some numbers. Well, for every 2 moles of silver nitrate, we have 2 moles of silver. For 2 moles of silver nitrate, we have 2 moles of silver. And 1 mole of silver nitrate was 169.87 grams per mole. Okay. Give that a shot. Do the math. And what we come up with is 0.035 moles of silver. Now you'll notice there are only 2 digits in my answer because there were only 2 digits in my problem. 2 sig figs. Now you try and do the one for copper, see if you can do it on your own, then come back. Okay, we always start with the information that we're given, which is 3.50 grams of copper. And we have to convert from grams of copper to moles of copper. Now once I have moles of copper, I want to convert to the same thing as the problem above me, which is moles of silver. Okay, so let's look at what our relationships are. 1 mole of copper weighs 63.546 grams. And moles of copper, well, let's see, we have 1 mole of copper gives me 2 moles of silver. Okay, so what I have to do is I have to sit down and do all this math, plug all the numbers in, and what I come up with is 0.111 moles of silver. Okay, so what is my limiting reactant? Well, clearly I can only make 0.035 moles of silver, which means silver nitrate is my limiting reactant, and I have excess. I have excess copper. That's what I have more than enough of. In fact, if you think of this, 0.035, you multiply by 3, and you get about 0.111. So there's about twice too much, twice more than what you need. Okay. So our problem asked, what's your limiting reactant? We figured that out. It's silver nitrate. And how much excess reagent is left? So I have to figure out how much excess copper there is, how much copper was not consumed in the reaction. So how do I do that? Well, I'm going to go to the next slide just because I need more room. And I have 111.111 moles of silver. I'm going to subtract 0.035 moles of silver. And that's going to give me 0.076 moles of silver. Okay, that was not produced. Okay, so now if I go and I use that 0.076 moles of silver, and I get rid of moles of silver, and I go to moles of copper, and from moles of copper, I go to grams of copper. Well, I know if I look back at my equation, and I have silver and copper, I have a 2 silver to 1 copper. I have 2 silvers to 1 copper, and I know that every mole of copper weighs 63.546. If I multiply this out, I come up with 2.4 grams of copper was not used. Well, since I started with 3.5 grams, 5 minus 2.4 gives me 1.1 gram used. Well, that makes sense, because I said we had about twice as much that we didn't use compared to what we did use, so that kind of makes sense. Right. Now, I'm going to just quickly show you another way to figure this out. Now, we produced 0.035 moles of silver. So if we produced 0.035 moles of silver, how many moles, how many grams of copper did we actually use? Well, let's convert from moles of silver to moles of copper. And then we can go from moles of copper to grams of copper. Well, we have 2 moles of silver, 1 mole of copper. 1 mole of copper gives us 63.546 grams of copper. Now, what we're doing here is we're looking at how much silver did we actually produce, hence, how much copper did we really use? That's what we're figuring out here. How much copper did we really use? And if we do the math, we're going to come up with that we used 1.1 grams of copper. Wow, look at that. It's the same numbers right there. Now, that actually is a way to check your work, should you decide you want to do that. I realize on a test you don't have time to do that. But if you were really in the real chemistry world, you would check your work to make sure you were right. So, we have 1.1 gram of copper that was actually used. Okay. Now, folks, we're done. And I know that was a long podcast, I'm sorry, but I had to give you at least 2 examples. When you start doing the worksheets, there are podcasts out there that explain every question on the worksheets. So when if you run into a problem, if you look at something and it says, his answer was 10, my answer is 4, that doesn't help you, you can go off and watch the podcast that actually works through every question on the worksheet. So if you have those, that could help you. Right, if you have questions, please see us in class. We'll be happy to help you. Have a great day, and we'll see you then. Bye-bye.